So moving on in our program, I'm very, very excited to introduce the second panel this morning, which is all about increasing reliability and resilience. What innovations in technology and system design can make the grid more resilient, flexible, and future ready? We have the honor to be joined today by Rick Kephart, VP of Technology at Emerson. We have Nathan Croker, the Chief Commercial Officer at EOS Energy Enterprises, Fang Pang, the R.K. Mellon Endowed Chair Professor at the University of Pittsburgh, Anna Siefken, Director of Policy Markets North America for Long Duration Energy Storage LDES Council, and also an alumni of the Scott Institute. And last but not least, the Ramtin Sioushansi, Professor here at Carnegie Mellon University, but also the Director of Carnegie Mellon's Electricity Industry Center. And I have tasked Ramtin with the exciting opportunity to moderate this panel. And this panel is going to begin with a short presentation from Ramtin about how this panel is going to go and to tee up kind of the topics that will be discussed today.
All right, well, welcome everyone, and thank you for the introduction, Daniel. So as Daniel said, the topic that we're going to be discussing today is how to increase reliability and resilience of electricity systems, looking both from a technical but also a policy-making perspective. What are the workforce needs? What are the needs in terms of supply chains to source the technologies and equipment that are required? Just to give a little bit of background and framing, reliability and resilience of the U.S., or more broadly the North American electricity system, I think is being challenged. There are a few things that are coming together. So one is that electricity infrastructure has been aging over the past several decades, and I would argue that in many parts of the country there's been a lot of deferred maintenance. Part of this is driven by the desire not to make the cost of electricity service unbearably high to customers. But of course, the flip side of that is if you're not investing in the infrastructure is deteriorating and at the same time not keeping up with what we're asking of it. We're seeing more extreme and more frequent extreme events. So, over the past weekend here, we saw that with a wind event that took place. And, I'd say the third thing is when you compare the way that people use electricity today to, even a generation ago, electricity is just a much more critical commodity and a much more critical service compared to how it's been in the past. So, what was at one time a technical novelty or luxury is today basically the lifeblood of being able to do things. The last thing that I have here, so this is an animation produced by a colleague of mine, and hopefully it'll, let's see, what do I need to do to get this animation? Okay. All right, well, if the animation was cooperating, what it would show is, so this is a map of eastern Massachusetts, and this would have shown over the course of about 3 days a major northeastern winter storm that hit all of New England, but the animation is focused on eastern Massachusetts. And what you would see is basically lots of cumulative precipitation, snowfall, wind, so on and so forth. And the other interesting thing that you would see, so there were like 2 green dots there. If the animation was going, the dots would grow, and there would be actually a little bit of a time lag. So what you tend to observe when you look at these types of data is a weather event comes through, the damage is not normally immediate, it takes a little bit of time for, soil to get moist, trees to fall over, so on and so forth. So what the animation would show is you would just see these massive green circles all over the map showing customers who are getting electricity service disrupted over the course of these 3 days. And of course, that is incredibly disruptive to them, harms economic activity, so on and so forth. So what we're going to be talking about is some of these questions that I have outlined here. Who's responsible for addressing these challenges, as was brought up during the previous panel? We no longer have vertically integrated utilities where there's a single firm that plans, operates, manages everything. Now it's kind of broken up and balkanized. You have a mixture of different regulators. So who should be in the driver's seat to see that these types of technical solutions to address these problems are implemented? Policymaking is, of course, critically important because at the end of the day, even if you say that someone is responsible, if there's not financial incentive to do something about it or not a way to basically, cover the cost of what these technologies entail, it's not going to happen. Electricity industry contends historically, I would say, with a fair amount of risk aversion. Firms tend to be conservative in terms of demonstrating and deploying new technologies. So how do we deal with that? And then there are workforce, manufacturing, and supply chain issues as well. So with that, I will allow each of the panelists to introduce him or herself and give a few minutes of opening thoughts about that, and then we'll go into questions and answers.
Do you want to start, or am I starting? All right, so it's wonderful to be here. I think I was at 2016, so really, really excited to be back on campus. Thank you for the opportunity. It's really great to see so many familiar faces. So I'm Anna Siefgen. I'm the Director of Policy and Markets for the Long Duration Energy Storage, or LDES, Council. So we are a global organization that is entirely focused on one mission, which is to drive forward emerging and existing technologies, to form markets, and to work on policy reform associated with 8-hour and longer long-duration energy storage. So based in Belgium, I am glad to still live in Pittsburgh, and am really, really excited for this conversation. So a quick primer about the LDES Council and the things that we think are really important, and many of them it's a solution set, a diverse set of technologies that can help to solve for some of the grid-related issues that we're focusing on today. And I'm so excited that we have other panelists here who are going to talk about that. Long-duration energy storage protects against prolonged outages. It reduces single points of failure. It enables high renewable penetration and reliability. It supports grid restoration. It strengthens peak resilience. It enhances community resilience. And it also provides stability and ancillary services. And so I'll talk more about that through our conversation, but that's a little bit on LDES. Very glad to be here.
All right, good morning, everyone. And my entire career actually has been on the research how to make electricity safer, more resilient, and more reliable. I remember when I was a PhD student at that point, and in 1980s, when PC were everywhere in office building, many buildings even come to the house, hold and computers. And at that point, the power grid experienced a tremendous stress from PCs because they generate harmonic currents. And those harmonic currents overheat transformers, excite oscillations, and or harmonic oscillations, and cause a lot of cable overheating, fires in the, even burn down and office buildings. We even have, movies and Hollywood movies featured the big issue with that. And so, at that point, my professor said, "You want to work? I want you to work on, how to make, electricity safer." And so that's my first research topic, and I hold that till this day. And then later on, worked on how to prevent, for example, and down the power line from sparkling and electrical sparks and ignite vegetation. It's like, a lot of fires, wildfires triggered by power lines in California, also in Hawaii. And right before that, I wrote an article, a research paper, how to, eliminate that kind of situation in nature. And that was a really coincidence, and got a lot of attention from, even got phone calls from California about, who's responsible. If we use your technology, we can actually eliminate that kind of situation, and who's responsible to that, and a lot of questions, and I cannot answer. And these days, I'm working on more, and down to the component level, to make transformers, cables, power cables, overhead lines, and capacitors, pole mount capacitors, those things. And active. This morning I heard from Rick and said the power grid, most the components are passive. They're just sitting there. And I know my daughter went to the high school. A squirrel got it to the transformer and burned the transformer. Okay. And also I know and a facility and a critical facility, snake got into a transformer and burned the transformer. So currently I'm working on what I call the first line of defense to make transformers and cables, everything active and responsive. So to make them AI ready. This morning we heard a lot, and we need a more reliable, resilient power grid for AI. But also we want to make a great AI ready. So operated and optimized by AI also, not just for AI. All right.
Good morning, I'm Nathan Craker. I'm the Chief Commercial Officer at EOS Energy. EOS is a OEM manufacturer of long-duration energy storage systems. We're a local company. Our manufacturing facility is right here in Pittsburgh. We're in the process of expanding that. We're very excited about it. And what we manufacture is a static zinc halide chemistry battery specifically designed for long-duration energy storage. We have it installed in front-of-the-meter applications, behind-the-meter applications, grid-scale storage, and it's a safe, quiet alternative to other technologies that are out there. I think this is going to be a very interesting panel today. I'm excited to be part of it. One of the questions that we got asked beforehand was, what are some specific things that we're doing as it relates to what REM team introduced to begin with? From our perspective, one, it's manufacturing, as I talked about. Two, it's policy. And three, it's workforce development. And we're actively involved in all three of those, and we'll talk a little bit more about that as we go through this today.
All right. Well, hello, everyone. Thank you very much for the opportunity to do this. I'm Rick Kephart, and I am the Vice President of Technology at Emerson Power and Water Solutions. And we're part of Emerson Electric, and we are located here locally in Pittsburgh in Cranberry Township, formerly a Westinghouse business back in the day. And we provide automation systems. We have a product called Ovations, and we provide automation for power generation. Humbly, we automate just north of 50% of all of the power generation in North America, and the largest percentage worldwide. We also do energy management systems and distribution management systems at Emerson. So I like to say that we excite electrons, and then we convince them to take certain paths through the grid. And so grid resiliency, I come at things from more of an operations and control aspect, being the automation systems. We're sort of the brains and the central nervous system of the grid. And grid resiliency has been for a while a big deal for us, and it is never been more important than now. I've been doing this for just north of 3.5 decades, and I have never seen an electricity market and an electricity demand and just the dynamics of the electricity system like we have today. Incredible opportunities and incredible challenges. And resiliency is probably right up there at the top. And we spend a lot of time, especially from an operations and control standpoint, thinking about that. When I think about resiliency, a lot of people say, oh, resiliency is avoiding failures. And I think we used to think that way. I think that now we have sort of focused on failures are inevitable, and a resilient system is not necessarily one that you never have failures. It's one that failures are not catastrophic and cascading. So you need to be able to gracefully fail gracefully fail, if that makes sense, and be able to handle that failure from a control system aspect. So that's what we spend a lot of our time doing, and looking forward to the panel and some of the discussions.
Great. Well, thank you for the introductions. And before we open it up to audience questions, I'm going to exercise my prerogative to ask a few questions that are particularly of interest to me. So let me start. Anna, I guess I'll direct this question towards you to start, but of course, all the other panelists, feel free to chime in. So I mentioned, we have this very fractured regulatory landscape between, federal, state, local levels, the industry. For about 2/3 of customers, we have this mix of transmission owners, GenCos, utilities. So how does your organization, how does LDES Council think about, who should be asked to bear responsibility for addressing these challenges? And then my kind of related add-on, what do you do to see that policymakers are able to the extent possible, keep pace with technical innovation?
So I guess we're starting with the billion-dollar question, right? To get right to the point. So the industry is very fractured, and we've talked about that. The whole last panel was talking about that. We have the federal level, which has FERC making the rules. It has NERC that is working on safety. Then you have the ISOs, the RTOs, the individual owners, the transmission owners, and then you've got your utilities. So who should own all of it? That is the heart of the matter, is that no one currently owns it. So I think that's maybe the obvious answer, but at the same time, it's what we work on day in and day out. So because of uncertainty at the federal level, most activities are happening outside of the federal level. Like there are a few things, like there's permitting reform that's coming out at the federal level through Rewire, which was a piece of not legislation, but a regulatory call that came out a couple of weeks ago. But what we're seeing is at the state level, there are significant activities because many of the states have been negatively impacted by the pull down against renewables, right? So there are 18 states or so that had contracts that were canceled. Many of those are red states, right? So you would think that would be something that we would move forward on, but actually no. We have wind projects that are being actively funded to stop production, to stop construction. And so it's a very kind of confusing time, and there's a lot of risk. So I know we talked about risk in the previous panel. There's a lot of risk for manufacturers. There's risk for developers, and looking for that certainty at the national level. So at the state level, we're seeing leadership, real leadership. So California, of course, but people always say California, that's separate. They do things differently in California. It's true. We have Texas and ERCOT, which is very active. But Virginia just came out a few weeks ago with a House bill and a Senate bill that would support a carve-out for long-duration energy storage. So they're saying, bring us something different. How can we set procurement so that one technology at one duration is everything that's necessary, when in actuality, we need an entirely diverse ecosystem, a diverse set of technologies to meet this growing demand? So we talk a lot about data centers, but I always think about the neighborhoods that are behind them, the hospitals that are nearby, the institutions that want to keep running. We want to make sure that those really, really spiky energy uses from a data center are smoothed out. That's one of the things that you can get with a really good long-duration energy storage system. And now the states are starting to value that. So I mentioned Virginia, Massachusetts, and New York are all coming forward and asking for language, Maryland. So these are places where we might have thought about doing this kind of storage technology. And by the way, this is power to heat, which is industrial process heat. For electrification is a huge area of focus, as well as power to power and power to X. So how can we use these emerging technologies that sort of expand upon what we already know with pumped hydro, which 90% of the current energy storage in the United States is in pumped hydro. But what I'm seeing is a lot of movement, a lot of activity, and a lot of interest in the manufacturing part. And then the reshoring. In fact, sitting with industry leaders, talking to regulators and saying, if you would allow us to bring what we have to you, we will all win. And that is kind of what we're looking for. So what do? We do those convenings, the bringing together, the policy work, the data and the insights that help inform. And so we are always looking for partnerships in order to do that. Because getting to the federal level is tricky, getting to the state level one by one, also tricky. But it is the work that is most important in 2026. I would say that we talk about infrastructure, we talk about 30-year decisions, 50-year decisions that people are making right now. The most important thing that we need to be doing is thinking holistically about how our energy system is going to come together to meet all of our needs 50 years from now.
Just to add on, I've been in deregulated power markets for about 23 years, I guess. I've never seen a rate of change like we're seeing right now. And you touched on data centers. That's a big part of it, right? So on the generation side, we've got more intermittent generation on the grid than we did, a couple decades ago. And on the load side, we're seeing extreme volatility on the load side. And we've been running these integration tests. You're seeing load that literally will fluctuate by 60% within milliseconds from these data centers. There is no generation out there that is capable of those response times. So we have to be anticipating that, and what's the technology that we need in order to support that, because with the Internet of Things and AI everywhere, it's not going to slow down, it's only going to continue, and we need to be ahead of that in terms of technology and how we're going to respond to that type of load, which we've never had to deal with before. So.
Great, thank you. So the next question, let me direct this towards you, Rick. So you mentioned that Emerson and you have focus on electricity system operations. So how do you see system operation evolving as a result of the changing nature of the threats to electricity systems? What skills do you think the workforce is going to need to be able to tackle those that haven't been needed in the past? Is this going to be vocational training, or what is going to be needed for the workforce to be ready to do this?
Sure. First of all, if I back up and think about the challenges from an operational standpoint, and first of all, when I define operations, I think of it as not just the control room operators that you might see at a power plant or at a grid control center. It's that, but it's also the supporting cast that you don't necessarily see unless you're walking around the plant, or whether it's engineering or whether it's the trade, folks, the electricians and such. But if you look at the challenges, I think that, there's, and this is certainly not an exhaustive list. This is just what I think of as sort of the biggest challenges that we see, is probably first and foremost from a resiliency standpoint is just the grid stability issues, sort of what we were talking about with the load dynamics changing. A lot of, over the past 10, 15 years, a lot of inverter-based resources have been added to the grid at the expense of rotating machines, rotating masses. So grid inertia and the ability, the sort of the stiffness and the stability of the grid in general has decreased because of that. And, in fact, you see some changes where, coal plants, for example, that were going to be retired soon because of the demand are being moved out to 2030, 2040, even 2050 in some respects because of that inertia issue. So I think that's probably the top item. The other thing that I just have to make mention, because this is always a concern, and as a automation supplier, this is one of the things that keeps me up at night is cybersecurity. I know this isn't a cybersecurity panel, but that is a really a very big threat. The other thing is sort of just the transition of generating companies, and this is really more of a generation thing. Generating companies transitioning from local operations to remote operations. And basically we think of it as control room consolidation. So, if you can imagine the traditional view of the generation side of the house, you would have individual plants, and each of those plants would have a control room, and then there would be a grid control center that sort of sent the instructions, to the individual plants for active power, reactive power, whatever it might be. What's been happening, and especially with all of the introduction of renewables, is that those control rooms are now being collapsed into what remote operation centers, and usually with remote operation centers, that means ultimately less people doing more things. And, one of the biggest issues, and I would say the second biggest trend, or actually the biggest trend, the second biggest trend being the remote operations, the biggest trend headwind that we've had for a while in the power industry is just the turnover, workforce turnover and attrition, where, people worked in the power industry for 30, 40 years, take a power plant operator, for example, and one day they retire, and 40 years worth of experience walks out the door that day. And they're replaced by people who typically are younger. I mean, they'd probably be retired too if they weren't younger. So, they're usually younger. And in a lot of cases, maybe they're even smarter, but certainly, usually much more adept at using technology as a tool. And so there's a great opportunity there. So those are probably the three big challenges that I see. And I think as one of the tools that I know that we've been working with extensively, utilizing extensively now, and it really has to do with that human component, that human factor, of workforce turnover being replaced by new, less experienced people, is AI, and now specifically generative AI. And it's kind of interesting. It's always a little bit of a humor thing to me. I think of the thing that is probably driving all of the demand is exactly what we're using in the technology, and it works out very well. From a skill set, there's a new skill set that I think is evolving certainly we see this, and I'm assuming this is outside of, I don't have a lot of visibility outside of what we do, but I'm assuming that outside of even what we do is being able to interact with an active AI type of system. I mean, that's a sort of a new skill set. You know, how do you utilize that for decision support to make better real-time decisions? And I think that's an evolving thing. I think it's a new thing, but it's something that, you know, we spend a lot of time thinking about from an operations and an automation system standpoint. And as far as the skill sets, I think if you look at operations in general, and you think about the, you know, not just the control room operators, but all the supporting cast, I think it's all of the above. I think it's both, you know, engineering and, you know, college type of, you know, like Carnegie Mellon kind of training, but also the trades. And I think if you look at the electrician requirements and the trade requirements, it's hard to find people. I don't know, as people, we're hiring people all the time. I don't know where everybody is, but it's hard to find people. It's very difficult to find people. It's even harder to find trade people. And, you know, there's a big demand for the trade people. So I think there's tremendous opportunity for young folks that are coming into the power system. We were talking earlier this morning, you know, some of us old folks, you know, we were power people when power wasn't cool, you know, but now, you know, this is a big opportunity, I think, for, you know, universities and vocational schools to be able to put people into the workforce, into the power industry.
Okay. So let me, so Rick, you were talking, I mean, you mentioned that real-time control is probably going to require more human-computer interaction. So Fang, let me ask you, do you think have we reached the point at which these types of events move too quickly for humans to actually be in the loop for real-time control? And as an addition to that, if you are in a world where you're relying on automated systems, how do you think about managing or mitigating the risk that automation could exacerbate reliability issues? And so to contextualize that, like we've seen some examples where control systems on inverter-based resources, either due to incompatibilities, you know, they create feedback loops where they actually exacerbate instead of mitigating an instability issues. So how do you think about?
Yes. And this morning we heard a lot, you know, humongous power demand, you know, by AI data centers. And that's one aspect, you know. And, you know, also recently, you know, a little bit digress here. For the, you know, for the AI, the critical load and resiliency and it's very crucial. You know, resiliency means, you know, and it's resilient to natural and human-made disasters. And so in that regard, for example, recently we developed a technology can tie a local distribution system, several feeders together to feed a critical load. That kind of operation so far for utility companies is a no-no situation. You cannot tie several feeders, loop around and create a mesh system. Okay, but you know, we developed what we call energy router, and fortunately, and you know, we developed that for a number of years, just sitting there, and fortunately, and we had a master student, you know, entrepreneurship, and he took that to the market and founded, you know, got the investment from New York bankers. And recently, they installed several units for the data center to improve the resiliency, even like a power outage, you know, to some feeders automatically, seamlessly, and the data center won't see that kind of power outage. So in that regard, we have a lot of technologies out there, but you know, now that's for AI, what I call it. I'm glad that, you know, and right now we're talking about how to buy AI, okay, the electricity system by and the AI. And the electric grid is the most complicated, largest living machines ever created by human beings. Think about that. And also, Rick mentioned, the control center. I visited several control centers during a normal day. You see those lights and lines, and you don't have a problem. But when you have natural disaster or human-made disasters, that operation, everything is beyond human being operation. We have to, automated by AI, operated by AI, optimized by AI. Now, how to do that? That's what we're working on right now. Currently, we really need to make all the from the infrastructure, the equipment level, the transformer level, the cable level, the capacitor, anything the level, make them responsive. They're passive. They're just sitting there waiting for something to happen. Okay, but we can make it. Today's technology, we can make them active, responsive, and AI ready. That's what we call. So that related to that, and I think there's a lot of opportunities for students come to this. Like Rick, I cannot say that again. It's a really exciting time to get to power this, the old-fashioned or also, it's our legacy system or industry here. So.
All right, thank you. So before we open it up to audience questions, I have one last question for you, Nathan. How critical do you see it that these technologies and devices be manufactured and sourced domestically? Do we have manufacturing and supply chain capabilities in place, or is that something that is going to take some time to develop?
Yeah, I think this is much needed. And I just visited Pennsylvania transformer, a big transformer, just 20 minutes off from here. And that's one of only two large power transformer manufacturers left in this country. Okay, and so and also some of my technology and developed first commercialized in Europe by Siemens, ABB, and definitely is much needed. This is from my first hand. I was fortunate, like I mentioned a moment ago, that the commercialization is because our entrepreneurs. We need more entrepreneurs and from our students. Yes.
Yeah, I think we've talked a lot about the growing complexity of the electricity grids. I think, no question, it's one of the most critical pieces of infrastructure that we have in this country. And that means it's critical from a national security standpoint as well as a resiliency standpoint. And the components that we're adding to the grid every day, whether it's distributed generation or storage, data centers, are getting more complex every day. I think if you want to really understand what it is we're adding to our electricity grid and make sure that it's secure and make sure that it's resilient, there's no better way than to build that right here in the US. And by the way, it's good for the economy, it's good for local jobs, and so we're very, very excited about that. As it relates to EOS, our product is invented by American minds, built with American hands, on American equipment, and all that's done right here in Pittsburgh. So we're a big proponent of domestic manufacturing and domestic products. The second part of your question was around supply chain and workforce. We specifically designed our product to be manufactured using all raw materials that are already available and used in other commercial processes. So it's a fairly simple bill of materials. It's a very simple manufacturing process relative to other technologies that are out there in the marketplace. And as a result of that, the supply chain already exists. We have to, continue to build and grow that supply chain, and we're doing that. But in terms of being able to ramp up production and meet the growing demand, we could add a couple gigawatt hours of manufacturing capacity every 6 to 9 months. And that lines up perfectly with where we see the growth in the industry. We can do that with our local partnerships. whether it's high schools, vocational schools, take people at that stage in their lives, put them through our apprenticeship program, working with the U.S. Steelworkers to do that, train our own workforce, develop them in order to work in the factory. And it's a very, very exciting factory to watch. It's all robots and automated manufacturing, but we'll train people to actually do those jobs. And then our partnership with CMU right here in terms of engineering and R&D level talent as well. And we've just, we opened up a new office building in North Shore to be able to attract talent and make sure that we've got some of the best and the brightest helping to continue to improve and design the technology that we've got. So yeah, I think we're ready for doing all this domestically.
I'll add to that, and I appreciate all of the work that you're doing in Pittsburgh. We know of 23 companies that are trying to build in the United States, 67 projects that have met a critical construction milestone, and 117 additional projects. That's just between now and the next year or so. Those are the announced ones. So we have significant interest in building and manufacturing in the United States. It's just a matter of whether we can get all of the policy and regulatory frameworks, including things like permitting, to where they need to be so that these manufacturing plants can be built.
Great. Well, thank you for humoring my questions. I could have talked to each of you for an hour at least individually. So, Daniel, I'll let you scour the floor for some audience questions.
Yeah, thanks for a great panel discussion. We have a few minutes for just a couple of questions. And if there are any students in the room that would like to ask the first question, we haven't gotten that yet, but we are here and ready for you. This is a university. We don't stop classes for Energy Week, unfortunately. So we have a question right here.
So my question is on onshoring and reshoring. So first of all, thank you for producing in the US. But my question is, what distinguishes your calculus from others' calculus? Because we see tremendous offshoring, right? So what is unique about you that you can actually onshore? And then the second question is, Chips and Science Act, how much did it play a role in like encouraging some of the manufacturing that Anna was talking about? And many of the provisions have not been rolled back. So I wonder whether the negative politics behind it is discouraging folks, or do people realize that many provisions are not rolled back, at least for Chips and Science? Thanks.
Look, I think there was a time in our history where we were looking at manufacturing offshore, and it was prior to COVID. And thankfully, some of my predecessors made the decision at that time to bring manufacturing back, or we may not exist today. It's been, you know, to your question, there are definitely some programs and some incentives that help enable domestic manufacturing. Our product qualifies for an incremental 10% domestic bonus credit under the big, beautiful bill that other technologies don't qualify for, so that's beneficial. We are fully FEOC compliant. That's another thing, because our bill of materials is domestic. So there's definitely some programs that help incentivize that. But as we continue to drive our costs down, whether it's design changes, large volume discounts from our supply chain, better labor and overhead absorption, we're very quickly closing the cost gap relative to other technologies. And when you look at the performance, we really are not competing directly with many of the other offshore products that are available, because we are specifically designed for long duration storage. It's an incredibly robust product, loves to cycle. It's a workhorse. It's designed for the most abusive energy cycles that we talked about earlier today. And it's designed for 4 to 16-hour durations. And so when you factor in the benefits associated with that, the incremental revenue stacking opportunity, the fact that you don't have to replace it every 4 to 7 years, it'll last for 25 years out in the field in these harsh conditions. It's just a really good quality product. And I think the playing field is level today. And I think it's increasingly incentivizing domestic manufacturing and domestic products going forward.
I would echo all of your comments. I would also say that the risk the risk profiles and the uncertainty. There is a bit of uncertainty, and that's pervasive. So we've seen some projects funding-wise roll back, but not all projects. So you mentioned CHIPS and Science. There are still those funding mechanisms, but because so many of them were pulled back, it created some uncertainty. That actually is, it's curtailing, it's changing, and we're seeing more and more manufacturing becoming more interested. I have a different company that I work with that has 52 projects that have been working for the past 20 years or so, 2 of them in the United States. So I think that we really do have to think about the entire ecosystem of how we're bringing manufacturing back to the United States, funding from the federal government or not. I think it's something like what READY is trying to do in the Pittsburgh region in terms of making sure that every part of the supply chain is available, that the universities are, like there's such a huge group of people that need to come together to make these projects come together, and you have to make it pencil. So we've recently put together 2 different reports that might be of interest. One of them is specifically about bankability. How do you make LDES bankable? How do you make sure that people are able to invest? And how do you find that kind of funding that can work in those projects? And the other is benchmarking. You mentioned prices falling. Our research shows that across all of the long-duration energy storage technologies, which are chemical, electrochemical, thermal, and mechanical, the prices between now and 2030 will fall in some categories as much as 47%. So those are real numbers. Those are things that are coming together, and it's because we're getting to scale. There's a perception that somehow long-duration energy storage is still 5 years away. In actuality, we're building projects. Things are happening now, and that is really good news for our economy.
Great. I think we have time for one final question. Anyone from the far end of the room? I just want to make sure we're not neglecting folks over there. But if not, any final questions for this session? All right. Well, please join me in giving a great round of applause for this wonderful panel.